Would you like to know what's in your future? What's going to happen years from now? What kind of job you're gonna get? Who your life partner would be? No, not with this mumbo jumbo. I mean in scientific way, with 100% accuracy. In ancient times, the world must have seemed pretty arbitrary. Disasters such as floods, plagues, earthquakes, or volcanoes must have seemed to happen without warning or apparent reason. Primitive people attributed such natural phenomena to a pantheon of gods and goddesses who behaved in capricious and whimsical way. There was no way to predict what they would do, and the only hope was to win favor by gifts or actions. Many people still particularly subscribe to this belief and try to make a pact with fortune. They offer to behave better or be kinder if only they can get an A grade for a course or pass their driving test.
प्रभु बस इलेक्ट्रॉनिक संभालने में नारियल फोड़ूंगा। नाग देवता मेरा फिजिक्स बचा लेना। रोज 1 लीटर दूध भिजवाऊंगा। हे गौ माता बस बस पासिंग मार्क्स दिला देना।
भगवान मालती और संगीता को अपनी बहन की नजर से देखूंगा। बस रिजल्ट संभाल लेना।
भगवान मैं 100 रुपए पर मंथ चढ़ाऊंगा। भगवान पक्का भगवान प्रॉमिस।
Gradually, however, people must have noticed certain regularities in the behavior of nature. These regularities were most obvious in the motion of the heavenly bodies across the sky. So, astronomy was the first science to be developed. It was put on a firm mathematical basis by Newton more than 300 years ago, and we still use his theory of gravity to predict the motion of almost all celestial bodies. Following the example of astronomy, it was found that other natural phenomena also obeyed definite scientific laws. This led to the idea of scientific determinism, and which publicly expressed by the French scientist Pierre Simon Laplace. What he said was that if at one time we knew the position and speed of all the particles in the universe, then we would be able to calculate their behavior at any other time in the past or future. The idea that the state of the universe at one time determines the state at all the other times has been a central tenet of science ever since Laplace's time. It implies that we can predict the future, in principle at least. In practice, however, our ability to predict the future is severely limited by the complexity of the equations and the fact that they often have a property called chaos. Now, those of you who are not familiar with chaos theory, this means a tiny disturbance in one place can cause a major change in another. A butterfly flapping its wing in Australia can cause rain in New York. The trouble is it is not repeatable. The next time the butterfly flaps its wings, a host of the other things will be different, which will also influence the weather. This chaos factor is why weather forecasts can be so unreliable. However, in the 20th century, there were two developments that shows that Laplace's vision of complete prediction of the future cannot be realized. The first of these developments was what is called quantum mechanics. This was put forwarded in 1900 by the German physicist Max Planck. Planck said that amount of radiation come only in packets or quanta of a certain size. The energy in the packets or quanta is higher for ultraviolet and X-rays than for infrared or visible light. It means that unless a body is very hot like the sun, it will not have enough energy to give off even a single quantum of ultraviolet or X-rays. This is why we don't get sunburn from a cup of coffee. Planck regarded the idea of quanta as just a mathematical trick and not as having any physical reality. However, physicists began to find other behavior that could be explained only in terms of quantized values. It was some time before people realized the implications of this quantum behavior for determinism. It was not until 1927 that Werner Heisenberg, another German physicist, pointed out that you couldn't measure simultaneously both the position and speed of a particle exactly. To see where a particle is, one has to shine light on it. But by Planck's work, one cannot use an arbitrary small amount of light. One has to use at least one quantum. This will disturb the particle and change its speed in a way that cannot be predicted. To measure the position of the particle accurately, you will have to use light of short wavelength, like ultraviolet, X-rays or gamma rays. But again, by Planck's work, quanta of this form of light have higher energies than those of visible light, so they will disturb the speed of the particle more. It is a no-win situation. The more accurately you try to measure the position of the particle, the less accurately you can know the speed and vice versa. Quantum mechanics doesn't allow us to make absolute prediction about the future. It only predicts the likelihood of different outcomes to happen and doesn't say anything about which one will happen. Einstein was very unhappy about this apparent randomness in nature. His views were summed up in his famous phrase, "God does not play dice." Other scientists were much more ready than Einstein to modify the classical 19th century view of determinism. Things get more weird and complex when we count black hole. We cannot, even in principle, observe the particle inside a black hole, so we cannot measure their position or velocities at all. Do the laws governing the universe allow us to predict exactly what is going to happen to us in the future? The short answer is no, and yes. In principle, the laws allow us to predict the future, but in practice, the calculations are often too difficult. To sum up, the classical view put forwarded by Laplace was that the future motion of particles was completely determined if one knew their positions and speed at one time. This view had to be modified when Heisenberg put forward his uncertainty principle, which said that one could not know both the position and speed accurately. However, it was still possible to predict one combination of speed and position, but perhaps even this limited predictability might disappear if black holes are taken into account. Peace.